Hi my dear students, I am Kedarnath. Welcome to my channel Make Mathematics Simple. So today I am going to explain top 25 questions in the topic probability. So probability, it is the most easiest topic, not toughest topic. So in this session I am going to explain some tricks in probability also, and wherever concept is there I am going to explain with detailedly. So don't worry. So if you watch this video, in KCET around 4 to 6 problems are asking, around 4 problems are asking in every year. But if you observe last 2018 and 19, they asked 6 questions. And in JW mains also they asked 1 question or 2 questions from probability topic. So if you watch this video till the end, then you will come to know so how much easy topic this probability. Okay, so this is the most easiest topic, don't worry. Okay, so look at the problems. So if P of A intersection B is 7 by 10, P of B is equal to 17 by 20, then what is P of A by B? So what is P of A by B? P of A by B is nothing but what? Probability of A with respect to B. Probability of A with respect to B. Okay, or probability of A given that the event B already happens. So what is the formula for this P of A by B formula? So it is equal to what? Probability of A intersection B divided by probability of B. Correct? Probability of A by B is equal to what? Probability of A intersection B by probability of B. So this denominator, numerator is same P of A intersection B. If they ask P of B by A also, numerator is P of A intersection B is common. Then what is the denominator? So here in A by B, what is the second here already happens event? B. So here we are finding probability of A with respect to what? B. So that is why we have to divide it with what? Probability of B. So in the given data, already P of A intersection B is given and P of B value is also given. If you use that values and if you substitute here, and you will get the answer 14 by 17. You will get what? 14 by 17. So just use P of A intersection B by P of B. So you will get the substitute the given values, you will get 14 by 17. So simple problem. Okay. So next look at this problem. Observe, if A and B are two events such that P of A not equal to 0. So P of A not equal to 0 means what? A is not an impossible event. A is some possible event. P of A is equal to 0 means what? A is an impossible event. P of A not equal to 0 means what? A is some possible event. Okay? And we have to find P of B by A in these two cases. Okay? So P of A is not equal to 0 and we have to find the probability of B by A when A is subset of B and A intersection B is equal to pi. In these two cases we have to find P of B by A value. Okay. So first case, in first case P of B by A is equal to, so what is the formula? P of A intersection B by P of A intersection B by P of A. Correct? So that means you are finding what? Probability of A with respect to probability of B with respect to A. Correct? So it is equal to formula P of A intersection B by P of A. So first case. In first case, what you will get the answer? Tell me now. A is a subset of B. A is subset of B. That means Venn diagram will be like this only. That means what is the common part? If A is a subset of B, the Venn diagram of A subset of B is like this. Then what is A intersection B? That means what is the common part of A and B? Nothing but A only. So that means the P of A intersection B value becomes what? P of A in first case divided by P of A as it is. So anyway P of A not equal to 0, then P of A by P of A value what you will get? 1. So that means when A is a subset of B, P of B by A value is equal to what? 1. Next, second case. So divided by P of A as it is. Second case, what is A intersection B? 5. So A intersection B is a null set. So then if you substitute A intersection B is 5, what do you get? P of B by A value, P of A intersection B by P of A, that is equal to P of pi by P of A. So phi is nothing but what? Impossible event. As it is impossible event, what is the chance of happening of an impossible event? 0, correct? So 0 by P of A. So 0 by non-zero number, what do you get? 0. So in first case, P of B by A value is 1. In second case, P of B by A value is 0. Okay. Next, look at the third problem. This is the JW problem. Third problem, JW problem. And it is a NCERT textbook problem also. So if you observe in second year, first exercise, objective problems. So this question is there. But it is asking in JW. So it is a 4 marks question. So if you are thorough that NCERT textbook, just by looking this problem, you can take the option so that you can save the much time. Okay. So listen. Let A and B are two non-null events. Two non-null events. So non-null events, non-zero events or possible events are one and only same. Non-null events means they have some chance of happening. Okay. Such that A is a subset of B. A is a subset of B. Then which one of the following is always true? Which of the following is always true? Okay. So A is a subset of B means again the figure will be like this only. Then we have to find according to the all 4 options P of A by B value. Okay. P of A by B value. Okay. So if they ask P of B by A, it is equal to 1. See, P of B by A value, what we got? 1. In under what condition? When A is a subset of B. But here what they are asking? P of A by B. Okay. So then P of A by B is equal to what you get? P of A intersection B by P of B. But what is A intersection B? A intersection B is same as A. So thus P of A by B is equal to what? P of A by P of B. So observe. So clearly first option is wrong. Next to last option also wrong. Because as A is a subset of B, P of A value is smaller than P of B. So P of A by P of B cannot be equal to 1 and hence P of A by B cannot be equal to 1. So first and fourth are wrong. Among these two options only is correct. So that means they are comparing what? P of A by B and P of A. Probability of A by B and probability of A. Probability of A by B and the probability of A. Okay. So which is correct among these two? Okay. So look at this. For this, so we have to find what? P of A by P of B. So P of A by B is equal to what we got? P of A by P of B. We have to check whether it is greater than or equal to P of A or smaller than or equal to P of A. So since always P of B is less than or equal to 1 only. P of B is always less than or equal to 1 only. So that means 1 by P of B, what do you get? Greater than or equal to 1. Reciprocal. Okay. So reciprocal of 1 is 1. As we have taken reciprocal, inequality will be changes. Then from this, what we can conclude? P of A by P of B is greater than or equal to P of A. That means what I did? I multiplied with what? P of A on both sides. So thus this P of A by P of B is greater than or equal to what? P of A. So that means P of A by B is also greater than or equal to what? P of A. Probability of A by B is greater than or equal to what? Probability of A. That was the answer. Okay. Set of problems. Okay. So before going to this solving these three problems, so just I want to discuss two definitions: mutually exclusive events and independent events. So A and B, two events A and B are said to be mutually exclusive events if the happening of one event does not will stop the happening of other event. That means happening of the event A stops the happening of B and vice versa. So such events A and B are called mutually exclusive events. That means the two events A and B are said to be mutually exclusive events, both events A and B does not occur simultaneously. So that means whenever if you conduct a random experiment, so whatever you are getting outcome, that outcome if it is favorable to A, it should not favorable to B. If it is favorable to B, it should not favorable to A. Such events are called what? Mutually exclusive events. In a simple sentence, A and B are said to be mutually exclusive events if A intersection B is null set. As A intersection B is a null set, then probability of A intersection B becomes probability of empty set, which is 0. And in this case, probability of A union B becomes what? Probability of A plus probability of B. So in which case it happens? When A and B are mutually exclusive events. Okay. Then when we two events A and B are said to be independent events, the happening of one event does not depending on the happening or does not happening of other event. Okay. So that means two events are said to be independent, they are not dependent. And if A and B are independent events, then probability of A intersection B is equal to what you get? Probability of A into probability of B. So when A and B are independent, what you are getting? Probability of A intersection B, probability of A into probability of B. That means here P of probability of A intersection B has some non-zero value. Because if here we are considering A and B are possible events. Okay. So then probability of A intersection B has some value when A and B are independent events. But if A and B are mutually exclusive events, then what is the probability of A intersection B? 0. That means that is impossible event. So if A and B are mutually exclusive, A intersection B is impossible event. If A and B are independent events, P of A intersection B has some non-zero value. So then A intersection B is some possible event. Here we are talking about, we have taken whatever we have taken two events A and B are some possible events. So that means if A and B are independent events, then they cannot be mutually exclusive events. Similarly, if A and B are mutually exclusive events, then they cannot be independent events. Remember this. Okay. Now, the first question is a concept. First question, if A and B are independent events and if P of A dash means P of complement of A, that means P of not A is 2 by 3 and P of B dash, that is P of not B is 2 by 7, then what is P of A intersection B? So just now discussed now. So if A and B are independent events, then what is P of A intersection B? P of A into P of B. So further that P of A can also be written as 1 minus P of A dash. Okay. Next to P of B can be written as 1 minus P of B dash. Correct? Because P of A plus P of A dash is 1. Then what is the P of A value? 1 minus P of A dash. And P of B value is 1 minus P of B dash. So why I am using this formula? Because they have given P of A dash and P of B dash values. Okay. So 1 minus P of A dash means what you get? 1 minus 2 by 3? 1 by 3. P of B dash is 2 by 7 means P of B is 1 minus P of B dash. So 1 minus 2 by 7 how much? 5 by 7. So thus this value, this whole value is 1 by 3. This whole value is what? 5 by 7. So 1 by 3 into 5 by 7 what do you get? 1 by 3 into 5 by 7 what do you get? 5 by 21. So that's the answer. P of A intersection B in first case is 5 by 21. Now look at the next problem. If A and B are independent events, if, so is it correct? A and B are mutually exclusive events? So wrong. So it is clearly it is a what? It is what in a conceptual question. Okay. Is it possible if A and B are independent events compulsorily P of A must be equal to P of B? No. They may equal, but it is not must. Is it compulsory that P of A plus P of B must be equal to 1? They may equal. Sorry, their sum may be equal to 1. Their sum may be equal to 1, but it is not must. So third option also wrong. So blindly you can put fourth option is correct. Because whenever A and B are independent events, then A dash and B dash are also independent events. Then P of A dash intersection B dash is equal to what you'll get? P of A dash into P of B dash. Okay. Further, P of A dash is same as what? 1 minus P of A dash is nothing but 1 minus P of A, and P of B dash is nothing but what? 1 minus P of B. So thus P of A dash intersection B dash is equal to 1 minus P of A into 1 minus P of B. That option is correct. Okay. Next. If P of A is equal to 0.5, P of B is equal to 0.3, and A and B are mutually exclusive events, then what is the probability that neither A nor B happening is? Neither A nor B happening is. So here A and B are mutually exclusive means A intersection B, null set. Probability of A intersection B is 0. Probability of A union B becomes probability of A plus probability of B. Why we are not getting probability of A intersection B? Because probability of A intersection B value is what? 0. Okay. So now according to the question, what we have to find? Probability of neither A nor B happens. That means A is not happening and B is also not happening. A is not happening means which event is happening? A dash event is happening. And B is not happening means which event is happening? B dash event is happening. So neither A nor B happening means what? A dash and B dash are happening. Okay. So that means according to the question, we have to find probability of A dash and means intersection B dash. So probability of A dash intersection B dash is nothing but 1 minus probability of A union B. Correct? Because A dash intersection B dash further it can be written as what? A union B whole dash. So probability of A union B whole dash is nothing but 1 minus probability of A union B. So but what is the probability of A union B in this case? Probability of A plus probability of B. So substitute probability of A 0.5, probability of B 0.3 here. Then what you will get? Final answer 0.2. Because 0.5 plus 0.3, 0.8. 1 minus 0.8 is 0.2. That was the answer. Problems, very simple problems. So first question, see, two cards are drawn at random from a pack of 52 playing cards. What is the probability that these two aces only? That means both cards are ace cards. Okay, so total 52 cards are there. Among those, how many cards are ace cards? 4 cards only, no? Okay. So according to the question, we have to find probability that whatever we have drawn cards, both cards must be ace cards. But available ace cards are how many? 4. So that means the favorable outcomes is nothing but what? Number of ways of selecting 2 ace cards from 4. This is the favorable cases. Total number of cases is what? Selecting 2 cards from the total 52 cards. So favorable cases nothing but what? Number of ways of selecting 2 ace cards from 4 ace cards, which can be done in how many ways? 4C2 divided by total number of cases or total number of outcomes is nothing but number of ways of selecting 2 cards out of 52. So that is nothing but divided by 52C2. Because we can select 2 cards from 52 cards in how many ways? 52C2. So favorable is 4C2, total number is 52C2. So that was the answer. So just simplify and you will get the answer. Okay. Next. 8 and 9 both are related to throwing a die 2 times. Correct? Throwing a die 2 times. So 2 dice, throwing a die 2 times, no. 2 dice are thrown simultaneously. So both the 8th and 9th problem, these 2 problems are throwing 2 dice simultaneously. Okay. So when we throw 2 dice simultaneously, okay, 2 dice thrown simultaneously, total number of outcomes 6 into 6. How many? 36 outcomes you will get. Okay. So what is the minimum total score obtained on the 2 dice? Because what is the minimum number on the each die? What? 1. So then minimum score will be what? 1 plus 1, how much? 2. And the maximum score is how much? 6 plus 6, 12. That means if you throw 2 dice simultaneously, then the sum of the numbers on the 2 dice obtained is either it is equal to 2 or 3 or 4, 5, 6, 7, 8, 9 or 10 or 11 or 12. These are the possible sums. Okay. Then how many favorable outcomes to get the sum is 2? Only one favorable outcome, that is 1 comma 1. That means first die shows 1, second die also shows 1. And how many favorable outcomes are there? Okay, to get total score 3. 2 favorable outcomes. What are those 2 favorable outcomes? First die shows 1, second die shows 2. That is the 1. Next to ulta, 2 comma 1. 1 comma 2 and 2 comma 1. Suppose in general, if k denotes sum of the numbers on the 2 dice when we throw 2 dice simultaneously, okay, then favorable outcomes is k minus 1 when that sum is less than or equal to 7, and it is equal to 13 minus k when that sum is more than or equal to 7. Suppose if you want to find how many favorable outcomes are there, to get the total sum is 8. Then total sum is 8 means k value 8. So first case satisfied, second case satisfied, second case. Okay, 8 is greater than or equal to 7, correct? So then the answer is 13 minus k. So k value is how much? 8. 13 minus 8 is how much? 5. So that means there are 5 outcomes which are favorable to the total score 8. What are those? 2, 6, next to 3, 5, 4, 4, 5, 3 and 6, 2. So this is the shortcut formula. So try to remember. Okay. Next. Here now look at the problem. Okay. So 2 dice are thrown simultaneously. The probability of obtaining a total score is 5. Okay. So now here k value is how much in this case? 5. K value is how much? 5. So k value 5 means the first condition satisfied or second condition satisfied? First condition is satisfied. So how many favorable outcomes? K minus 1. So k value 5 means 5 minus 1 how much? 4. That means there are 4 outcomes which are favorable to the sum is 5. What are those? 1, 4, 2, 3, 3, 2, 4, 1. Okay. Divided by total number of outcomes is 6 into 6, 36. So thus the 4 by 36 is how much? 1 by 9. Over. Now next problem is same model problem. See, in a simultaneous throw of a pair of dice, what is the probability of getting a total more than 7? More than 7. Remember, more than 7. So that means sum is 7 is included, not included? Not included. So more than 7, strictly greater than 7. But maximum sum how much? 12. Maximum sum is how much? 12. So that means we have to find probability of sum is 8 plus probability of sum is 9 plus probability of sum is 10 plus probability of sum is 11 plus probability of sum is 12. Okay, don't write this step in the examination, just to understand purpose I have written this. Now in all these cases, denominator is nothing but total number of outcomes. Total number of outcomes is how much? 36, correct? So I am writing like this now, 1 upon 36 into, just you write favorable outcomes to total score 8. So total score 8 means k value of how much? 8. In first case k value is how much? 8. So 8 is satisfying first condition or second condition? Second condition. So according to this condition, what is the answer? 13 minus k. So 13 minus, in first case what is k value? 8. 13 minus 8 how much? 5. Next second case, what is k value? 9. 13 minus 9, 4. Next third case, k value how much? 10. 13 minus 10, 3. Next case 11. 13 minus 11 how much? 2. Plus last case 12. So k value 12. So 13 minus 12, how much? 1. So 1 by 36 into 5 plus 4 plus 3 plus 2 plus 1. So if you add all these, what will you get? 15 only, na? So 15 by 36. So 3 5s are 15, 3 12s are 36. Thus, required probability is equal to what? 5 by 12. Set of problems. So in all these three problems, just to one line answer. So reading the question only takes time, but writing the answer is just hardly 5 seconds. Okay, so the first one is hardly 2 seconds only. If you understand that question, by reading that question only you can take the answer. See here, first look at that 10th question. If A and B are mutually exclusive, then what is the probability of A or B? So R is nothing but union only. So that means we have to find what probability of A union B, and give if P of A is equal to 3 by 5 and P of B is equal to 1 by 5. As A and B are mutually exclusive events, A intersection B null set, probability of A intersection B 0. Hence probability of A union B is equal to what? Probability of A plus probability of B. Correct? So that means just adding these two over. That was the answer only. See, probability of A or B is nothing but probability of A union B. As A and B are mutually exclusive, probability of A union B is equal to what? Probability of A plus probability of B. So that is equal to probability of A how much? 3 by 5. Probability of B how much? 1 by 5. So thus the answer is 4 by 5. So 4 by 5 it is equal to what? 0.8. So thus probability of A or B is 0.8 over. Next look at 11th and 12th, same concept. The concept is a multiplication theorem. But see, by looking at that problem, how we come to know we have to use multiplication theorem. Okay. So just here observe without replacement. Without replacement. So in any problem, this is the just a trick. Without replacement is there. That means there we have to use their multiplication theorem. And no need to remember multiplication theorem also. Just to using our sense only we can write. Because it is objective, it is not subjective, it is not required that step by step answers. Okay. So just use your sense, then you can write the answer. So first I am solving this 12th question. Okay. So here see, a bag contains 17 tickets numbered from 1 to 17. 17 tickets numbered from 1 to 17. That means on the first ticket number on the first ticket is 1, number on the second ticket is 2, like that. Number on the 17th ticket is 17. Next, a ticket is drawn at random. A ticket is picked at random. Then another ticket is drawn without replacing the first one. So first we have drawn one ticket. Now we are not replacing first ticket. Again we have drawn one more ticket. So then what is the probability? What is the probability that both may show even numbers is? What is the chance that whatever we have drawn two tickets, those two tickets must show what? Even number. Okay. So here total how many tickets are there? 17 tickets. Out of 17 tickets, 1 to 17, no, 1 to 17. So starting number is odd number, last number is also odd number. That means a number from 1 to 17, number of odd numbers only more than the number of even numbers. Okay. So anyway it is begin with 1 only, now 1 to 17. What is 17 by 2? 8.5. What are the nearest integers to the 8.5? 8 and 9. 8 and 9. So in 8 and 9, which is the more number? 9. That means from 1 to 17, 9 numbers are odd numbers, 8 numbers are even numbers. 9 numbers are odd numbers, 8 numbers are even. So from 1 to 17, 8 are even and 9 are odd. Now the question is what? a ticket is drawn. First we have taken one ticket, okay. So, and without replacing that first ticket, we have drawn one more ticket. That means how many tickets we have drawn? Total 2 tickets without replacement. Then the probability that both are showing even numbers. So first you write probability of drawing first ticket is even. So total, how many even number tickets are there? 8. Among these 8, we can draw any one of the even ticket na? So that can be done in how many ways? 8 ways. Divided by total number of tickets, how many? 17. Okay. So into. Now next we have to find probability that second ticket is also even. Second ticket is also containing even number. Okay. So under what condition? First ticket is also drawn, that is containing even number, and we are not replacing that ticket here. Okay. So after drawing one ticket containing even number without replacing, then how many even tickets are left? 7. Now in this situation, we are going to draw one more even ticket number. So which can be done how many ways? Favorable cases is 7. Total number of cases is 7 plus 9, how much? 16. Because after drawing the first ticket, we are not replacing. So automatically initially 17 tickets are there, and while drawing second ticket, how many tickets are there in the box? Only 16. So that is why we are getting total cases 16. And the second ticket also we need to draw what? Even numbered ticket. Already first ticket is what? Even numbered ticket only. Okay. So after drawing one even numbered ticket without replacing, okay, then how many even tickets are left? 7. Now in this situation, we have to draw what? One more even ticket. So in this situation, what is the number of favorable outcomes? 7. So 8 by 17 into 7 by 16. That was the answer. So if you simplify 8 ones, 8 twos, so 7 by 34. Okay. Now look at the 11th problem. So a flashlight has 10 batteries, out of which 4 are dead. Out of which how many are dead? 4 are dead. If 3 are selected without replacement, see, without replacement, and tested, then the probability that all 3 are dead. So it is also purely a PUC problem. So these two, 11 and 12, purely PUC problems only, not so difficult problems also. So total 10 batteries are there. Total 10 batteries are there, out of which 4 are dead. That means the remaining 6 are good only. Remaining 6 are good. Okay, now we have drawn 3 batteries, one after other without replacement. Okay, one after other without replacement. What is the chance that all 3 are dead? All 3 batteries are dead. So what is the chance that first battery is dead? 4 upon 10. Correct? So after drawing first battery, so still how many batteries are left? 9 batteries are left, out of which, because here we have to do -1, here also we have to do -1, because we are not replacing now. Okay, so out of which 3 are dead, 6 are good. Okay, then what is the chance that in this situation drawing second battery is also dead? 3 by 9. Next, into what is the chance that third battery is also dead? What you will get? 2 by 8. Correct? 2 by 8. So simplify this. 4 into 2, 8. Cancel. 3 ones, 3 threes. So what is the answer? 1 upon 3 10 30. 10 into 3, 30. See, just to one line answer. Over. So look at the next problem. If A and B are two events such that P of A is equal to 0.8, P of B is equal to 0.6, and P of A by B is equal to 0.5, then what is P of A dash by B? What is P of A dash by B? So just a property, just it is a property. P of A dash by B is equal to 1 minus P of A by B. Just first property in conditional probability. Okay. So it is equal to 1 minus, already probability of A by B is given. What is the probability of A by B? 0.5. So 1 minus 0.5 is equal to what? 0.5. So that was the answer. Okay. Just using property. Okay. Next. Look at the next problem. So this is the JW problem. So two integers are selected from the set capital A is equal to 1, 2, 3 and so on 11. Given that sum of the selected numbers is even, conditional probability that both numbers are even. So here we have two events. So first event is what? The sum of the selected numbers is even. Okay. So let capital A is equal to capital A, or you take a E and F. Suppose capital E is the event that sum of the selected numbers is even. Sum of the selected numbers is even. And suppose capital F is the event. Both numbers are even. Both numbers are even. Both are even. Then according to the question, what we have to find? Given that the selected numbers is, sum of the selected numbers is even, that means the event is already happens. Then what is the conditional probability of F? So E is already happens. Then what is the conditional probability of F? That means we have to find probability of F by E. What do you have to find? Probability of F by E. So probability of F by E is equal to what? Probability of F intersection E by probability of E. Okay. So now first look at this E. So to get, first we have to find probability of E. Before that we have to find number of favorable outcomes. So to get the number of favorable outcomes here, so what is the given set? 1 to 11. So 11 by 2 is how much? 5.5. What are the nearest integers? 5 and 6. So 5 even numbers or 6 odd numbers. 5 even and 6 odd. Because begin with the odd number, end with odd also. No? Okay, there will be odd number of, from 1 to 11, odd numbers only more. So there are 5 even numbers, 6 odd numbers. Now here it is given, the event is happens whenever we are selecting two numbers, those two numbers sum must be even. And we know that sum of two even numbers is even and sum of two odd numbers is also even. Correct? So that means the event E will happens if we select both are even or both are odd. Correct? So both are even. How many ways it can be done? 5C2. Because there are only 5 even numbers, 2 even numbers can be selected. How many ways? 5C2. Or means plus. Both are odd numbers. Both are odd numbers. How many odd numbers are there in the given set? 6. So in how many ways we can select 2 odd numbers from 6 odd numbers? 62 ways. Divided by total numbers. Total number of outcomes. So total how many elements are there in capital A? 11. So in how many ways we can select 2? In how many ways we can select 2 numbers? 11C2 ways. Okay. So divided by 11C2. Next. Probability of E. This is probability of E. Okay. Next, I am calculating E intersection F. What is the event? E intersection F. So event E is what? Whatever we are selecting, two numbers are even numbers or both are odd numbers. And F, when it happens, when both are even. Then E intersection F. In both events, what is the common thing? Both are even. So E intersection F, this event will happen, when whatever we are selecting two numbers, those both numbers are what? Even numbers. Both are even. So probability of E intersection F is equal to, so total outcomes is 11C2. And the probability of intersection F means this E intersection F event happens when both numbers are even. Whatever you are selecting, two numbers are even. Out of 11 numbers, 5 are even. Okay, so then we have to select how many even numbers? 2 even numbers, which can be done in how many ways? 5C2 ways. So substitute in this formula, you will get final answer. I am writing directly. P of F by E is equal to 5C2 by 5C2 plus 6C2, because this 11C2 get cancelled. So 5C2 value 10 and 5C2 value 10, 6C2 value 15, 10 plus 15, 25. So 5 2s are 5 5s are. So thus the answer is 2 upon 5 or 0.4. Over.